On PSC3-1, we're going to talk about and identify translations, rotations, and reflections within a plane, so on a coordinate graph. We're also going to apply concepts of rotational and reflectional symmetry. Notice you do not need to know stretches or shrinks. I will touch on them today, but you will not be tested on them. So on Schoology, there is hopefully a PDF explaining how to create an account on BrainPop, and then I also posted the link there, as well as instructions on how to log in and find the video. BrainPop has a great video about transformations that frankly teaches it better and faster than I can. And of course you have the terrible joke at the end to look forward to. If you can't get it to work, if the instructions are confusing, don't stress out. I would encourage you to give it a shot to log in, but I also know this is not something that we have done before. So you will have all the info that you need here as well. So if my transformation stays exactly the same, so if I start with a triangle and I move it over and I get the exact same triangle, so they are identical in every way, they are congruent. It moved, but it's still congruent. When that happens, we say that the pre-image and the image are congruent. And we can also say that it's a rigid transformation. So if they're the same size and shape, it's a rigid transformation. If the size or shape changes, so if only one side gets moved and it got way stretched out, or if the whole thing got bigger or smaller, that's non-rigid because the image is not congruent to the pre-image. And just like with potatoes, everything either is rigid or is non-rigid. You cannot be both, and you cannot be neither. So just like being a potato, you either are a potato or you are not a potato. You can't be both. Transformations refers to the moving of all of the points according to certain rules, and we will break down those rules tomorrow. For this class, you will need to know rotation, reflection, and translation. Again, you do not need to know stretches and shrinks, although I will touch on them today. So a translation is when you move all the points the same distance along parallel paths. In elementary school, you learned this was a slide. So if you pick up your cat from here and you move him over here, the cat stayed the same, you just scooted him over. That's a translation. Your reflection is when you get a figure's mirror image. And in elementary school, you learned this was called a flip. So when your cat looks in the mirror and it sees its reflection, that's a flip. In geometry, we call it a reflection. And if you turn your cat over, so you twist him or you knock him over, that's kind of rude, but all the points rotate the same number of degrees, that's a turn. We will call it a rotation. A dilation then, we touched on earlier this year, and it's when you multiply everything by the same scale factor. In elementary school and next year as well in higher algebra, if it gets bigger, you'll call it a stretch. If it gets smaller, you'll call it a shrink. Okay, both of those fall under a dilation. There are two types of symmetry you'll need to recognize. Reflectional refers to when you can reflect it over a line. So you could fold your butterfly exactly in half and things match up perfectly. Rotational is when I can turn my image around a point and it would line up. So I can rotate this around this way, and eventually this arrow ends up where that arrow was.